This problem is from Capacitor and this uses the concept of equivalent capacitance and Gauss law. So we have been given 4 metal plates. So this plate S1, S2, S3 and S4, and these are a square plates, that is this side and this side are equal. This side has a length A, then this side also has a length A. So area of plate is A square. Now the distance between plate is also given. So this distance is D, this is D and this is also D. These plates are parallel. Problem also says the distance between plate is much smaller than the side of the square plate, that is A. The constant C naught, it is given, and this is equals to epsilon naught A square by D. So this is epsilon naught and this is area, that is epsilon naught times area divided by D. Now we have to find the equivalent capacitance in various cases. Now these cases are given in list 1. For example, the first case is the capacitance between S1 and S4 with S2 and S3 not connected. So what will be the capacitance in this situation? You have to choose from here. So options are given. So let us try to solve this problem. I will consider different cases one by one. So let us consider the first case, that is part P of the problem. And in this case we have to find the equivalent capacitance between S1 and S4 with S2 and S3 not connected. So this is S1 and this is S4 and these two plates are not connected. So let us represent this situation. So these are 4 plates and S1, S4, we have to find the equivalent capacitance between S1 and S4. So let us connect this by a battery. Now once you connect with the battery, so this is the positive terminal and this is the negative terminal. The battery will send charge to this metal plate and let us say this charge is Q. Now how much charge will appear on this plate? And this is again a metal plate. And this you can derive using the Gauss law. Basically you should be knowing that if this charge is Q, then this charge is minus Q. Let us try to use the Gauss law to find the value of charge on this surface. Now if I consider this rectangular surface, we can calculate electric flux through this surface. Now in this region electric field will be parallel to this line. So electric field will be like this. So electric field is parallel to this line. But the area vector for this line, basically this is a surface, for this surface is in this direction. So area vector makes an angle 90 degree with the electric field vector. So E dot ds, that is the flux, that E times ds times cos 90 and cos 90 is 0. This means electric flux contribution for this portion will be 0. Similarly, in this case also electric field and area vector are perpendicular, so contribution is 0. Now what about this surface? This surface is inside the metal plate and we know that inside the metal plate electric field is 0. So electric field is 0 in this region, E dot ds will be 0 because electric field itself is 0. Similarly for this portion, that is again in a metal plate, electric field component is 0, so the flux will be 0. So now overall I can say the total flux through this surface is equals to 0. And now if I apply the Gauss law, if the total flux is 0, then total charge has to be 0 inside this closed surface. This means this will have minus q amount of charge, because minus q plus q, this will be 0. So this will have same amount of charge, only thing is it will be negative. Now if this face has a negative charge, then from where this charge came? This charge is basically redistribution of charges on this metal plate. So this means this side I will have a plus charge, same amount of plus charge. So this is minus q, and this side I will have plus q, because total charge on this plate has to be 0. This is not connected through a battery, this is the isolated plate. So only redistribution of charges can take place. Charges cannot be created or destroyed if this plate is isolated. So I can say this side I will have plus q amount of charge. Now if I use the same idea, that is this kind of surface, if I draw this surface here, I can say if this is plus q, then this face will have minus q. And if this is minus q, this has come from redistribution, this will have plus q. Now this charge plus q, then again same idea, this one I can say this will have minus q. And this is also true because battery has given positive charge here, q amount of positive charge, then battery should give negative q amount of charge to this plate. So that's why this is minus q. This means all the charges are equal, that is q, q, q. So now let us say the capacitance between this plate and this plate is C1, and this plate and this plate is C2, and this plate and this plate is C3. Now all the charges are equal, so I can say these three are in series. So, and each capacitance can be given by, that is C1 equals to C2 equals to C3, and that is A epsilon naught by D. So this is the formula for capacitance, and A is area, that is A square epsilon naught by D. Now in the problem given, it is given that this term is equals to C naught. Now the three capacitance or three capacitor C1, C2, C3 are in series, and we know that the equivalent capacitance of series combination, that is 1 by C equivalent, is equals to 1 by C1 plus 1 by C2 plus 1 by C3. So that is 1 by C naught plus 1 by C naught plus 1 by C naught, that is 3 by C naught, and if I take the reciprocal of that, equivalent capacitance will be C naught by 3. Now let us consider the next part, that is part Q. In this case it says we have to find the equivalent capacitance between S1 and S4, the same plates, with S2 sorted to S3. Now S2 and S3 are connected. So this was the initial situation that we did in previous question, that is previous part. Now these two plates have been connected. So once you connect, what will happen? This charge and this charge will neutralize. So this will have plus q and this is minus q, so this will neutralize. So this charge will disappear. So now there is no charge on this face and this face, so this is not a capacitor anymore. So these two plates are acting like a single plate, and one side have a minus q charge and another side we have plus q charge. So in this situation we have only two capacitors. This is C1 and the capacitance between this plate and this plate, that is C2. Now C1 and C2 both are in series because this is plus q, this is minus q, plus q, minus q. So these two are in series. Now if you remember, the equivalent capacitance in this case will be two capacitance, each value C naught, the equivalent capacitance in series will be C naught by 2. That is same formula, 1 by C equivalent equals to 1 by C1 plus 1 by C2, and that will give you C equivalent is equals to C naught by 2. Now let us consider the next part, that is part R. In this part you have to find the equivalent capacitance between S1 and S3 this time. This is S1 and this is S3 with S2 sorted to S4. Now this S2 is sorted to S4. So let us first connect S1 and S3 with the battery. So this is the battery, because we have to find the equivalent capacitance between S1 and S3. So we have to connect S1 and S3 with a battery. This is the positive terminal and this is the negative terminal. And S2 and S4 are sorted. This means we have to connect this with a wire. Now what will happen? This battery, this is the positive terminal of battery, will give some charge to this plate. Let us say this gives Q amount of charge that will appear on this face. There will be no charge on this face because there is no plate this side, and this you can verify. So this charge is Q. All the charge that is given by the battery will appear on this surface. Now similarly, this has given some amount of charge, the same amount of charge. So battery, negative terminal of battery has given negative Q of charge. Now some portion of that charge will appear on this face and some will appear on this face, because this side we have a plate. So some charge will appear this side and some charge will appear this side. So let us say battery has given Q amount of charge, that is a negative charge, some amount, that is Q1 appeared on this face. So what will appear on this face? This side I will have Q minus Q1, because the total charge is given Q. Now these two plates are facing to each other. Same idea, if you use the Gauss law, take this boundary surface, bonding surface, and then you can prove that if this is minus Q1, then this side we should have plus Q1 charge. So the surfaces that are facing each other will have equal amount of charge. Only thing is their sign will be different. One is positive, another is negative. Now as I said, this is plus Q, then this will have minus Q, because this is isolated plate and this is facing to this side. So this is minus Q, and this is minus Q, then this will have plus Q minus Q1. So this is Q minus Q1 with a negative sign. So this will have plus Q minus Q1. You can now verify. Now what is the total charge on this system, this plus this plate? So this is Q, Q minus Q1, and this is Q. So Q1 positive, and here we have Q minus Q1 positive. So total positive is Q minus Q1 plus Q1, that is Q, and that is same as negative charge. So total charge on this plus this is 0, and that should be, because this is an isolated system. So this plate and this plate has not been connected by any battery. This is an isolated plate. So this system should have 0 amount of equal charge or equivalent charge. Now the potential difference between this and this will be same. Why? Because this plate and this plate are connected. So this plate and this plate has same potential. So, and this is a common plate. So difference between this and difference between this and this will be same. So these two plates are basically having same potential difference. So we can show this situation. So this is S2, S3 is this capacitor, S3, S4 is this capacitor, and these two are having same potential difference. This means these two are in parallel. That's why I have shown this is in parallel. Now this plate is having Q charge, and the equivalent of these two are also having Q charge. So this means equivalent of this two will be in series with this system, that is S1. So this is S1. So now I can find the equivalent capacitance. So this is in parallel and this is in series. So this is in parallel, so equivalent will be 2C0 and this is C0. So equivalent capacitance in this case is given by C1 into C2 divided by C1 plus C2. So C1 is C naught, and C2, which is equivalent to this plus this, that is 2 C naught, and this divided by C naught plus 2 C naught, that is 2 by 3 C naught. Now let us discuss the last part, that is part S. And in this case we have to find the equivalent capacitance between S1 and S2. So that is this one and this, with S3 sorted to S1 and S2 sorted to S4. So let us first connect S1 and S2 with the battery, because we need to find equivalent capacitance between these two. And we have to connect S3 to S1 and S2 to S4. So S2 is connected to S4 and S1 is connected to S3. Now the charge distribution I have already shown here. So this gives Q amount of charge. So this goes here, and this will give negative Q amount of charge. Some amount of charge will appear this side and some will appear this side. And this plate is also connected. So let us try to first understand the charge distribution. So this is the positive plate and this is negative plate. Let us say the negative plate of battery gives a Q amount of charge. Among that Q, some is this side, some is this side, and some has flown to this plate. So let us say this side has a charge of Q1 and this side has a charge of Q2. So how much charge flown? Because total is Q, so Q minus Q1 minus Q2 has flown, and that will appear this side, that is Q minus Q1 minus Q2. Now same charge has to appear on this face, only thing is this will be positive. So this is same amount, that is Q minus Q1 minus Q2. So this charge is positive charge and the magnitude is Q minus Q1 minus Q2. Now this surface has Q2 charge, then this will have Q2 charge. And this surface has Q1 charge, then this will have plus Q1 charge. This means from here Q minus Q1 charge has flown. So Q minus Q1 charge has flown, some has come this side, that is Q2. So what is left? Q minus Q1 minus Q2, that is here. That is same as this charge, Q minus Q1 minus Q2. So you can use this idea to draw the charge distribution. You can also check on isolated plate, the charge should be equal to 0. But in this case there is no plate that is isolated, because this is connected to the battery and this is connected to the battery, so this is also connected to the battery. This is connected to the battery, somehow this is also connected to the battery. So that thing that is charge on isolated plate is 0 is not useful here. Now let us see the potential difference, and that is the important part. Even if you have not able to redistribute the charges, you can solve this problem, because the potential difference between this plate and this plate, let's call it delta V, and that will same as this plate and this plate, because this plate is connected to the negative terminal of the battery and this is positive terminal of the battery, and this has same potential as this. This means this plate is also connected to the positive terminal of the battery. So this is positive terminal and this is negative terminal. So again the difference will be delta V. Now this plate is connected to the negative terminal of the battery and this plate is connected to the positive terminal of the battery. So this difference is delta V. This is the positive terminal. So somehow indirectly this is connected to the positive terminal. So again the potential difference is delta V. So let's call this as capacitance C1, C2, C3, or you can call C1, C2 and C3. So all these three capacitors are in parallel. So equivalent capacitance in this case will be simply C1 plus C2 plus C3, that is 3C naught. So in this case the equivalent capacitance is 3C naught. So I hope you enjoyed this problem. This is a beautiful problem, and if you like my videos, please share with your friends, like on my channel and subscribe to my channel. I will see you in the next video. Thank you.